Okay, so today we present EmoTuner. So EmoTuner is a playlist generator that is aiming to be capable of transitioning the listener from the current emotional state to another. So it takes three inputs: sentences describing users' current and desired emotions, and users' Spotify account containing playlists. EmoTuner uses these three inputs to output a playlist with emotion transitions that can guide user from the current emotion to a target one, while preserving users' genre preferences. And this playlist is also uploaded to users' Spotify account. So the motivation for this project comes from a very simple observation. People often use music to regulate their mood, and yet most existing music platforms like Spotify mostly recommend songs based on single genre or listening history. So here is a quick example of of EmoTuner's workflow. Users start by giving permission to EmoTuner so that EmoTuner can upload playlists to their Spotify account. And then on a terminal, users can enter two sentences, one for the current emotional state and one for the desired emotional state. And then EmoTuner uses this input to output a playlist on the terminal, like so. Portfolio playlist is uploaded to users' Spotify account. Users can enter a title for the playlist, and playlists can appear often like that. To build EmoTuner, we use an open source Spotify dataset from Kaggle containing 110K songs with rich song metadata. And that includes track name, valence, energy, which is also known as arousal, and track genre. Specifically, the valence and energy values in the dataset are used to categorize songs into different mood labels like happy, angry, and sad. During playlist generations, songs are selected and ordered based on their valence and arousal values. So to make sure that EmoTuner actually generates meaningful mood transitions, we manually select a small set of songs from the dataset. And then we listen to each one of them, check their VA values, and assign mood labels to the songs. The goal is to have mood labels with corresponding ranges in VA space so that songs can be classified into correct and different mood categories.
This is the architecture of our system, where the emotion extractor will take input of current and desired states from the user. It will determine the start and target emotion labels and give a mood transition curve, which is used during playlist formation. And below emotion extractor is the genre extractor, where it will call Spotify NCP server and ask the user to log into their Spotify account to authorize the system to access their existing playlist. And from those playlists, it will give a genre distribution, which also used during formation. The new playlist will be formed and be accessed by the evaluator and then finally be uploaded to the user's Spotify account. During playlist formation, it will take two outputs from the previous entities and to select 5 candidate songs at each emotional step in the transition curve. And then it will also get their corresponding lyrics from Lyric API, and so the selector will read the lyrics, give a lyric score, and finally at each step it will select one winner that has the highest score in terms of the VA, valence arousal, and lyrics. The new playlist will be formed and be passed into the evaluator, and the evaluator will calculate the valence arousal score and lyric score using the same method, but this time is in terms of the entire playlist and the transition curve. And it will determine if the combined score passes the threshold of 0.8 and tell the system whether it should retry again or upload the playlist to the user account. We will be evaluating the result based on two metrics. Mean squared deviation will show us how well the formed playlist follows the transition curve, and while genre distribution will measure how much user's preference is preserved after formation process. By comparing the result of the system against the single prompt agent, the system is able to achieve better mean squared deviation, however a lower genre distribution, which is due to the limited size of the data set. And we also try other emotion labels that were not defined within the system. In this example, is overwhelmed to focus. However, the result was not ideal as the sound trace did not reflect the emotion. And this is due to not enough emotion labels during the classification process.
So from our results, a few important takeaways became clear. The first is we need more emotion labels, as many nuanced moods can be mapped onto the same VA point if we only have 4 labels. So MSD can appear good even when the playlist is not emotionally correct. The second is the current lyrics API we use has a 500 requests per day limit, and that constrains large-scale experimentation. So for the next steps, we plan to implement a more scalable solution. And future work also includes building a UI for the system, increasing generation speed, and improving use of GitHub for collaboration. Thank you.